Hey, welcome back to the config bench. I'm John. In lab 3, we ran 3 circuits, measured voltages and currents with 2 inexpensive meters. Paired those readings to the Quicks calculations, and I told you each time that the numbers will be close, but they won't be identical, and that's due to tolerances of components and within the meters and components that we choose to work with in our labs. Today we're going to explain exactly why. This is Ohm's law, and once this clicks, everything on the bench starts to make sense. We're going to start by pulling up those same 3 schematics just as a quick reminder of what we're working with, and then we'll get into the math. Don't worry, it's simpler than it sounds. This is not, and also just realize this isn't a math class. We're going to be using a calculator. Once I display the formulas, we'll be using a calculator. I recommend that you get a notepad right now and get a calculator, whether it's on a computer, a iPad, phone, or just have a calculator, staring calculator. It'll be very handy to have with you. So if you don't have that, stop and pause this and go get it, and then we will begin. All right, well, here we go. We are into going to review the original circuits that we did in the last lab. Here is the first one. It's a single resistor, and what we're showing is that we have a 6.87 volt source of power, and we have an amp meter. So from the positive side of our power source, which is battery, we're going through the amp meter to the resistor and through the resistor back to ground and the negative side of the battery. We also have a voltage meter, that we use to measure. So this is the first circuit that we did in lab 1. And then as well in the first set of labs was lab 2. And we did another series circuit, 9-volt battery, an amp meter, and now we had 2 resistors, both of them 47 ohms, and this is called a series circuit. And the difference here is our voltmeter we measured at the midpoint, and we also measured at the top and the ground, and we found that that we had different measurements due to voltage drop going across the resistors. And then in our last lab, lab 3, we had a similar, source of voltage, 7.9 volt battery going through the amp meter, and then it's going up to the original 2 resistors, R1 and R2, and now we've changed the values to 470 ohms, but now we've added 2 more resistors here, and those are 470 ohm resistors in series, but they are in parallel with each other. And we came up with different voltages and different currents because of this. And so what we're about to do is go through Ohm's law and explain and explore how we can calculate the whatever's missing, because Ohm's law is made up of 3 values: voltage, resistance, and current. And so we're about to go through and explore that. Okay, well, here we go. Now we're going to start discussing Ohm's law. And, it starts out with Ohm's law is one equation, 3 variables, and everything on this bench comes back to this. And if you have your calculator out, good. I want you to follow along and punch these numbers in as we go. Verify the math yourself. That's how it will stick. So Ohm's law is V equals I times R. And what is V? V equals voltage. I equals current, and it's measured in amps. And R equals resistance, So there's the three components that make up Ohm's law. So voltage, you know, when we talked about voltage and we were over here in the first circuit, the battery I was using dropped down to 6.87 volts. So we know the voltage. Current, the ammeter was reading our current. Right now that's an unknown. And then the resistance, RT, the total resistance, is a single R1 resistor, and it was 47 ohms. So let's plug these into the formula. So we know that voltage equals 6.87. Current is unknown, and resistance equals 47. So if we take this formula, V, which is the 6.87, equals the unknown I times 47, we can also write this as 6.87 divided by 47 equals I. And so let's get our calculator out. Let's do the math on that one. So 6.87 divided by 47 equals, so there it is, 0.1461702. We're only going to go over four digits. So let me move this out of the way. So I ended up being 0.146. 14617. So we'll just say 1. And that is in amps. And that also we could write it as 146.1 milliamps. And so there's the formula for this circuit here. We now know what current is. So with a 6.87 volt source of power, you divide that by 47 ohms, and you come out with 0.1461 amps. Or you would refer to it as 146.1 milliamps. And so that concludes our review of Circuit 1. So I recommend writing these formulas down. V equals I times R. V is voltage, I is current, and it's measured in amps. R is resistance. So V in this case was 6.87. We didn't know what I was, but we knew what R was. And so you can transpose this formula in a few different ways, and we're going to do that down here. So V equals I times R. We could also say V divided by I equals R, or we could say V divided by R equals I. And what we chose was this formula here to figure out circuit 1. So if you're taking notes, I recommend taking notes because that might be confusing at first, but it's a relatively simple formula. Feel free to use your calculator, and we are going to go on to the next circuit. So this concludes the Ohm's Law demonstration for Lab 1. One resistor, a 9-volt battery, breadboard, some jumper wires, and 2 inexpensive digital voltmeters. Ohm's Law puts the math behind what we are looking at on the bench. The math works. In the next video, Ohm's Law Lab 2, two resistors in series, same battery. We're going to see how resistance adds up, how voltage is split, and what happens to current when you put components end to end. If you haven't subscribed yet, hit that button, and I'll see you in Ohm's Law Video 6, Lab 2.